Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good day everyone. In this video we discuss about scalar product. So look at the linear outcome first. Right. So we will learn about how to find scalar product. Use the properties of scalar product and find the angle between two vectors. And lastly, find the direction cosine for non-zero vectors. Right, so firstly look at the definition. A scalar, or in other words, usually we refers to dot product. So the scalar or dot product between vector A and vector B are defined as, so dot product is an expansion according to, so look at here, A1 and B1 is refers to I component, A2 and B2 J component, and A3 B3 K component. So we expand according to the component I, J, K. So we multiply together the component from vector A and vector B, as you can see over here. So now we get properties of scalar product. Right, the first one, the dot product between two same vectors, that is A dot A equals to magnitude of A squared, vector A squared. And then the second property is here, so dot product A dot B equals to B dot A. Okay. And then number 3, so the dot product between the addition of two vectors, so A dot of B, vector B plus vector C, so is equivalent to A dot B plus A dot C. So something like we expand, okay. And then number 4, so if you have a constant C at the front of vector A, so we dot product with vector B, so we can put a constant outside, so we can dot product first between vector A and vector B. Or similarly, it is equivalent if we bring the constant to the next to the second vector, that is vector B. So it is the value is equivalent, right? So remember, the scalar here means we have a value only without the direction, okay? So that's why it is called scalar. So let's say the value is 20, so it is also 20, and this one also 20, okay? And then, so if 0 dot product with any vector, so the answer is 0, okay? And also there is another equation here that relates the dot product with the angles. So that is the dot product between vector A and vector B equivalent to the magnitude of vector A times magnitude of vector B cos theta. So this, we will use this formula to prove the properties that we already discussed in the previous slide. So we are using this equation actually to prove that, especially the first one, I think, A dot A equals to magnitude of A squared, okay? Because it's same vector, so cos 0, so cos 0 is 1. So that's why magnitude A times magnitude A, we got magnitude A squared, okay? Right, as I said earlier, from the formula, we can rearrange and to find the angle. So from the formula here, So we bring cos theta as a subject. So here we can divide the dot product with magnitude of vector A and magnitude of vector B. Right, apart from the properties of scalar product, there is also three rules. So depending on the angle. Right, the first one, if the angle is 0. So if the angle is 0, the two vectors, that is vector A and vector B, we consider as a parallel and same direction. Okay, if the angle is 0 degree. So remember, if the question mentioned about parallel and same direction, so straight away we know the angle is 0. So when we substitute into the formula of dot product, so cos 0 will be 1. So 1, we can eliminate the cos theta, so only the magnitude of vector A and magnitude of vector B. Okay. Okay, next, the second rule. What is the unlike parallel? So unlike parallel is actually the two vectors seems like a parallel but in the opposite direction. So if the two vectors are parallel by opposite direction, we call it as a unlike parallel. So in this case, as you can see in the diagram here, so actually the angle between these two vectors is 180 degree. So cos 180 degree is -1. So the dot product between vector A and vector B equivalent of negative of magnitude vector A and magnitude of vector B. Then the third rule, if the two vectors are perpendicular, so the angle between the two vectors is 90 degree. So cos 90 degree is 0. So remember, always remember, cos 90 is 0. So 0 means 0 times the magnitude is 0. Okay, so the dot product will be 0. So this is one of the main rules that very useful. So in order to show the two vectors are perpendicular, that is using the dot product, so the dot product would be 0 if the two vectors are perpendicular to each other. Okay, so I think that's all for the concept of the dot product. So remember to looking for the next video, we will discuss a few examples regarding the scalar product. So until then, thank you very much. Bye bye.